Let's recall the SOHCAHTOA, which we used with right triangles to either find some of the sides of the triangle when you're given an angle, or maybe given the angle and you're looking for one or two of the sides. So SOHCAHTOA has to do with right triangles, and we mark up the triangle as we've talked about before. For example, if I wanted the sine of 30, if I go to this 30, 60, 90 triangle, we recall that if you know the smallest side and you multiply by 2, you get the hypotenuse. And if you multiply by radical 3, you get the other leg. So if that was given to us, we could actually find the cosine, sine, and tangent of 30. So the sine of 30 would be the opposite over the hypotenuse. Opposite over hypotenuse. 6 over 12. So remember, we looked at the angle, marked the opposite, and we always knew the hypotenuse was the biggest side. The cosine would be the adjacent over the hypotenuse. So in that case, it would be 6 radical 3 divided by 12. And finally, the tangent of 30 degrees would be the opposite over the adjacent, which is 6 divided by 6 radical 3. If we do the arithmetic for that, so you're looking at the arithmetic, obviously 6 divided by 12 is going to be 1/2. And 6 radical 3 over 12, I did the calculation over here and got 0.866. And 6 divided by 6 radical 3, that one here, I get 0.577. If I go directly to the trig buttons on the calculator, it will give me these same numbers. And I did that up here. Sine of 30, cosine 30, and tangent of 30. We get the same exact decimals. I'm not going to get the radicals up here. I'm going to get the decimal form. So the calculator's got every angle you'd ever want stored in it. So quickly, if you went to our old friend, the 45, 45, 90, remember the two legs are going to be the same size. Let's just say they're both 7. So then, obviously, then the tangent of the 45 would be opposite over adjacent, which would give us 1, just as the calculator would tell us tangent of 45 is 1. Okay, so what happens, though, with other angles, like, 22 degrees, or maybe 75 degrees? Those angles there are actually, you can get the decimal values off the calculator. What happens when the angle is not in a right triangle? Well, that's going to be a useful tool under 2 laws that are going to be studied soon, the law of cosines and the law of sines. That's used for triangles that are not right triangles. So this angle here, let's say, I don't know, just how about 125 degrees? It's obviously bigger than 90. The calculator will give us a cosine value, a sine value, for 125 degrees. But look at the strange answer. It's actually a negative number. So what in the world could that be? How could they get a negative value? Well, you're not working with opposites, adjacent, and hypotenuse anymore. So we're going to need another technique to get the cosine, sine, and tangents of angles bigger than 90. What if it was actually even bigger than 180? Well, that's a possibility. So if you fix this side of the triangle and you rotate the other side of the triangle, we get a very large angle here that's over 180. It could be, I don't know, let's just say 250. That's a big angle. It's not in a triangle. You can't put it in a triangle, but that doesn't mean in a scientific or an engineering situation you wouldn't have an angle of 250 degrees. Well, there's a sine value. It's in the calculator. Again, this one turned out negative again. And we're going to look in a minute on why these turned out negative and how we can even talk in terms of something bigger than 90 degrees. One last example. How about the sine of 610? Now that sounds ridiculous. How can you have 610 degrees? Well, again, let's fix this side and rotate the other side of the triangle, of the angle, the angle. Go past that point, rotate around kind of like the hands of a clock, and it ends up back down here. So we're looking at an angle that's actually bigger than 360. Well, it is actually 250 more than 360. Which then justifies, at least kind of justifies, the fact that their sine values would be the same, because theoretically they are, in all practicality, the same angle. At least visually, they're the same angle. Okay, and this process, the way to work this process is we're going to use a circle, and that circle is going to have radius 1, and we're going to talk about the different parts of the circle and the angles. Like, for example, our friend over here, 125 degrees. 125 degrees, if you fix this side of the angle and you spin the angle and have it point over here, we get 125 degrees, and this circle will give us the sine cosine values that we need to get.